So my name is Valentina Bergami. I work in sales and marketing department at Sacmi Packaging and Chocolate in the wrapping business unit. And today I'm going to give a brief overview of our company and our portfolio, and then introduce a case study we have chosen for you today. But before starting, let me stress out, it is with great interest we look at the new findings and innovations in the field of packaging materials. We as machine manufacturers believe it is the only way we have if we have strong partnerships with strong strategic partners like Futamura. We believe that is the only way we have to properly shape our machines today and also make them fit for the new challenges of the future, for the new challenges to come. You know, in the past, we had some very interesting and challenging projects that started with wrapping film producers asking to run some tests, or even customers, so downstream partners to us, asking us, will you help us trying out this new material my marketing is considering for our new products? And I confess those were occasions we maybe back then didn't seek out 100% intentionally. But as you can imagine, those occasions brought us great benefits in terms of expertise, knowledge, new ideas. So we have learned that lesson. And this is why over the past years, all of our business units have built their own labs, which are dedicated to this, to experimenting, to making tests, with machineries dedicated to running tests, also in the field of packaging materials. And so in this perspective, I think today's webinar is the perfect occasion for not only sharing our experience with compostable films, but also for possibly reaching out to new contacts, reach people who might be interested in test capacity. So after this, feel free to contact us for your new ideas. Having said that, let me start by introducing the Sacmi group with a couple of figures. Sacmi is an international group founded in 1990. It is a world-leading supplier of technology to various industries: ceramics, rigid packaging, beverage, advanced technologies and materials, and packaging in chocolate. It counts 4,572 employees and operates in 80 companies in 27 countries worldwide. Now, a couple of words to the mission, as it is described in our sustainability report of 2020. And I bring that up because I think it is pretty much in line with the message we wanted to convey this today. So point number one of the mission is research. Sacmi invests greatly in cutting-edge research to drive technological innovation. Point number two, the capacity to generate technological synergy across different industries inside the group and put the results out for the customers is one of the cornerstones of the Sacmi group. And last but not least, quality. Sacmi always sets eye on product and service quality to provide effective responses to the real needs of the markets it operates in. Now, if we come to our company specifically, Sacmi Packaging and Chocolate, it is composed by 4 business units: process and molding, primary and secondary packaging, wrapping and tray forming. These 4 BUs are located in 3 regions of northern Italy, and the company is represented on the market by 2 very well-known historical brands like Carlo Montanari and OPM, which operate in the industry since 1907, so quite a while now. And as you might see, we provide for turnkey solutions, literally from the small chocolate bean up to the carton tray and the carton box through the whole process. Our wrapping business unit, where Flavio and I work, is located in Castel San Pietro in the city of Bologna, not far from the headquarters of the Sacmi group in Imola, and right in the middle of the so-called packaging valley you might have heard of, which is so called in Italy for the impressive number of companies active in this specific industry and segment, packaging. So we are the wrapping machines specialists of the group, and we produce entirely in our plant in Castel San Pietro, which is very important to know. And this is our product portfolio. We have an impressive range of wrappers for planes. We literally cover all the wrapping styles available on the market. We have also wrappers dedicated to hollow figures and eggs, surprise eggs, Easter eggs, but we also have wrappers for chocolate, small and big bars, and for soft, hard and chewy candies. And precisely on candy wrappers, we wanted to make our focus today, because it is on our newly launched candy wrapper. We have tested the Nachoflex by Futamura, the film by Futamura. So here's the wrapper we've chosen. It is called H1K. It is a monostyle machine, so dedicated to just one wrapping style, in this case, double twist, and it wraps hard and jelly candies. It has a hybrid technology designed to overcome the restrictions of the mechanical disc motion and achieve top feeding efficiency and guarantee top versatility. This is a wrapper that, depending on the product you want to wrap, can reach up to 1,000 pieces per minute. And as I said, is the wrapper we have run the tests. We have chosen to run the tests with Nachoflex. Now, let me give the floor to Flavio, who is going to take you through the wrapping cycle from the point of view of the wrapping film and dig more into the tests we have run. I guess it's all from me, and thank you very much.
Okay, thank you, Valentina, for the presentation of this test. Now we are talking about the case study that we done on our H1K machine with the Nachoflex wrapping material, and we go more deep in the technical aspects of the management of the film on the machines. So this is the machine, and we in this machine, in the left part of the machine, we feed the products. In the right part of the machine, we feed the film, and we have to put our attention on 3 sections. The first one is the unwinding of the paper of the film from the reels. The second one is the cutting section, in which we develop the exact and precise length of the foil and cut the film. And then the wrapping section, in which we perform the final aspect of the product. Then, starting from the first task, the big work that we have to do in this first part is to transform the continuous motion of the unwinding in an intermittent motion of the machine, because our machines are all intermittent. So we realize this in 2 sections. The first one is this, the first unwinding of the film. Let me show you a short video in which we can see that for this operation, we need that the film has to be very, very elastic and flexible to avoid breakages of it during this unwinding section. And then the second one is the final buffering of the film before the cutting. In this section, we really transform the continuous motion in intermittent motion, but also we have some stoppages due the no product, no paper system of our machines. So if we don't have product in the feeding system, the machine continues to run, but the film has to stop and restarts. And also in this section, as you can see, we need flexibility of the film. Then the film cutting is done unwinding the film by pushing it forward on top of the candy. We cut the film only when the final foil is over the candy to have the precise positioning between the product and film. So during this operation that you can see in this short video at high speed, 950 pieces per minute, just to have an idea of it, of how is the speed of the machine. In this video, you cannot see some format parts just to allow the vision of the unwinding of the paper. Obviously, this video is not very interesting for understand what happens, but this in low speed shows you that for do this job, we need a different, completely different mechanical characteristic of the film. The film has to be rigid because it's not supported and has to maintain their planarity, okay? So the third task is the wrapping and twisting. The first issue, the first operation that we do on the product is the forming of the tube around the products. Also in this case, we need to combine two mechanical characteristics, flexibility to fold it, and also rigidity to maintain the tube during the movement of the products. And then the final one is the twisting, in which we need a big resistance of the film to this mechanical solicitation. And also we need low memory effect. So we have that we need that the film after this twisting maintains the twist in their final positions. What are the possibility quality defects that we can find after this process? The first one is the wrong, is the broken twist. If you see a broken twist in a product, is a product that you cannot put in the market. Normally, this kind of defects is typical with paper-based material. And with this material, you can also find another defect that is the broken film that you cannot see when the product is closed, wrapped, but you can see it only when you open the twist. Obviously, in this case, it's not a matter of look of the product, but it is a big matter in terms of shelf life of the products, because the product is not closed. Another defect can be a completely open twist. This is a defect typical with material with big memory effect, like polypropylene, for example. And another defect can be a loose twist. In this case, the product is not open, is closed, but the look is not good. So we tested this material, Natureflex 30 NM, to understand what happens on the machine at high speed. The film is the Natureflex, the product is this rectangular shaped candy, and the machine is our H1K at 950 pieces per minute. Just to have an overlook of the test, a short video in which you can see the feeding system. We fill the pocket of the disc just to phase the product with the film and the wrapping sections. Then the results. With this material, we noted the no defects that we see in the previous slide. So in our case, the test is the result of the test is very, very good. The product is closed. The twists are ever closed without reopening. The wrapping is tight to the product, and also the repeatability of the quality is very, very high. So for us, this is a material that we can propose to our customers to run at high speed with compostable materials. Last one, not only double twist like we've seen in this video. We've seen a video with double twist for candies, for example, but also for chocolate pralines like this. We can use this material. We can use it with other wrapping style that needs the same mechanical characteristics, like twist on top for Boeros products or twist on side for rectangular chocolate pralines. So with this, I hope I was able to show you with these slides and videos what in practice happen on the machines, and why the mechanical characteristic of the wrapping material are so important for our point of view. Thank you for your attention.